Everyone, and welcome to another amazing video on fractions. GoFormative number 24. Now I skipped 23 because 23 is a bunch of you practicing the stuff that you've learned with decimals, and I think you just have to pick a couple problems. So I am on to 24. Now I'm not going to do probably any other video on fractions ever again in my life after I do this video here. So if you need fraction help, just watch this video and I'll practice as much as I can with you and then never again. But you will always have a record of it that I did tons of fractions. So let's begin. First one, 1/3 plus 1/3. 1/3 plus 1/3 is 2/3. How do I know that? The bottoms do not add. Just keep the bottom the same. The tops do add. That's why it's 2. These are things you have to remember when you're adding and subtracting fractions. These are simple rules, but you have to remember that bottoms do not add. Okay, so what are you going to do here on this next one? If the bottoms don't add, but the tops do. Okay, 3/3 is the answer there. So why is 3/3 answer 100%? Because 3/3 is 1. 3 divided by 3 is 1. Why was this answer 2/3? Why was that 66%? And how would I know that? You can grab a calculator and you can do 2 divided by 3 in your calculator. It'll be 0.66. Just remember 0.66 times 100 will give us 66%. And technically that should be 66. Maybe rounded. Let's just do it rounded. That sounds good. All right, let's do, well, you know that one now. We just, yep, you're a pro, Let's do this one. Let's do that one. 1 1/2 plus 3 1/2. The bottoms are the same, C2 and 2. So let's just keep that like that. Let's add 1 and 3 together first. What's 1 plus 3? 4. Okay, now we're going to keep the bottom number and then add the tops. 1 plus 1 is 2. So 2 over 2 is actually 1, isn't it? So we really have a 4 and a 1, which is 5. So the answer for this one is going to be 5. Another way you can look at this as this is 1.5, this is 3.5, and you're adding these together, you're going to get 5. Let's do one with a different denominator, so I have to help you change that over. Here we go. 3/4 plus 2/5. We need to get the denominators, these bottom numbers, that we can't add this right now. You can't do 4 plus 5. Can't do that. But we need to get them to be the same number. We can do that by multiplying both of these by numbers that help us get the bottom numbers to be the same. So the question is, what does 4 and 5 have in common? And again, you can just write it all out. 4, you can just count your 4s. 4, 8, 12, 16, 20, 24. Count your 5s. 5, 10, 15, 20, 25. Do you see any number that's the same in both? See that? So how many times did it take me to count my 4s? 1, 2, 3, 4, 5 times. So 5 times. And how many times to count my 5s? 4 times. So 4 times. What this does is it makes our fractions a little bit bigger. They don't change the problem at all other than they look different, but they're still the same problem. So this is now 15/20th because 3 times 5 is 15 and 5 times 4 is 20. And this is 2 times 4 is 8 and 5 times 4 is 20. And 15 plus 8, again, we're not going to add the bottom numbers. But 15 plus 8 is actually 23. So now we're sitting at like 23/20th. In this case, that is the answer. But what if they wanted a mixed number? And a mixed number would be this. How many times does 20 go into 23. And it goes in once. How many left over? 3. So that is the other way to rewrite that. Okay, moving on. I just showed you that. This problem is pretty much the same style. You're gonna do all that work. You can pause the video, go back and look at it. The beauty of 1 plus 9/5 is that it's 1 and 9/5. The ugly part about 1 plus 9/5 is that 9/5 is not good looking. It's an improper. We like it to be a mixed number. So let's deal with that first. How many times does 5 go into 9? And it goes in once. How many left over? 4/5. So you have to know this. If I know that, let me rewrite it this way. 1 plus 1 and 4/5. Well, now that's doable. The answer is just 2 and 4/5. And if you look at your answer, which is kind of funny, it's in an improper form. But I've actually taught you a way to get this back into improper by multiplying the bottom numbers and then adding this top one. So what's 2 times 5? It's 10. 10 plus 4, 14, and then keep that bottom number the same. That's what I call the C move. Although it's a backwards C, so maybe it's a backwards C move. And it's not really a C, is it? It's like a U? Okay. Anyways, I think you have all the skills you need to keep trying these. This one's pretty tough. I'll do this. It'll be like one of the last ones I do regarding this type. You can tell I'm really excited to not do any more fractions. But that is okay. They're good practice. We need the same bottom number. So what does 2 and 7 have in common? 2, 4, 6, 8, 10, 12, 14, 16. And then count your 7s. Do you see anything that's the same? Yes, I do. So I'm going to basically multiply this one by 7/7, but this one by 2/2. And I'm going to have 2 new fractions. Okay, scoot all that down. And let me get my new fractions. 26 over 14 plus 21 over 14. And you might ask, how'd you get those numbers? 2 times 13 is 26, and 2 times 7 is 14. 3 times 7 is 21, and 2 times 7 is 14. So all I did was take my problem, make it a little bit bigger, but now look at the bottom numbers. They're the same. So we don't add the bottom numbers. We just add the tops. What's 26 plus 21 is 47, and you're looking for that, which is what you see right there. If we wanted to turn it into a mixed number, we could. We just have to ask ourselves a question, how many times does 14 go into 47? And I think it's like 3 times with some left over. 5. How to graph. Graphing, you're going to start at, this is your y-intercept, so you're going to start right here at 1. And then you're going to go up 2 over 1. So here and here, and then you make a line, straight line. Use a straight line tool. Show your work and graph this. Make your own graph in there. There is no place to start at the end. And I've mentioned that before, but I'll do it again. If it says y equals 2x or y equals negative 3x, if there is no spot for the y-intercept, that means we get to start where? You guys remember the name of that? The origin, which is what location? Right here, 0, 0. So on this problem here, you're going to start at the origin. But then you're going to go down 3 over 1. How come? Because it's negative. Just remember, your down 3 looks like this. 1, 2, 3, and your over 1 is still this direction. So down 3 over 1. So down 3 over 1. So your graph should look like something like this. Okay. As beautiful as that, by the way. Explain how to graph y equals x in words. Well, y equals x is the very basic fraction when you teach someone how to graph linear equations. There is no y-intercept, so I just told you where do you start if there's no y-intercept. You start at the origin. And this one's tough for middle schoolers because there's no numbers in front, so they don't know what to do and where to go. But you have to remember there's some invisible numbers here. So there's an invisible 1 in front of the x because what is 1 times anything? It's that thing, right? So 1 times x is x. So that's why the 1 is there, but we don't need to show it. So it is going to go up 1. But how much is it going to go over? Well, the question would be, what's secretly divided here? It's invisible. Why? Because what is 1 divided by 1? It's 1. So I don't need the invisible 1 underneath everything. Like, for example, if I just said, hey, here's the number 3. No one, if we're just doing 3 plus 4 and moving on with our life, nobody cares about what's underneath it, right? But when you're graphing, you have to know that every whole number is actually secretly a fraction, right? 3 is really 3 over 1. 4 is 4 over 1. 5 is 5 over 1. That's important when graphing because these are directions, like up 3 over 1. You know, if you have 5, it's not just up 5 and that's it. No, it's up 5 and over 1. Or on the last problem where it said negative 3, we need to know there's a 1 under there because we're going to go down 3 and we're going to go over 1. Solve and graph. Solve and graph. These are inequalities. These are adding like terms. I've been going over these for the last couple videos. I'll do this one with you. You guys can watch, and then if it helps you, you can do the next one on your own. 2 times the quantity of x plus 3 is greater than 12. And then they want us to graph that on a number line. Okay, sounds great. So 2 times x is 2x, and 2 times 3 is 6. Bring down the greater than 12. Now it's just a 2-step inequality. So originally it's a 3-step. I did the first step. Now I need to subtract 6 on both sides. And it's 2x is greater than 6, because that's what 12 minus 6 is. So what times x is 6? So I'm going to divide both sides by 2. X is greater than 3 is the answer. And I show that on my graph by just find out where 0 is. You get to decide, it's fine. And then put 1, 2, 3, there's 3. Make an open circle at 3 and then shade. So the question is, do you know why it's an open circle? These symbols get open circles, but these symbols get closed circles, just so you know. Less than, greater than. This is a less than or equal to, greater than or equal to. If you see these, closed circles on the number line here. And if you see these, we have open. The shading is just the direction in which it's going. See that arrow's pointing this way? So we're going to shade the way it's pointing. If they're this way, we're going to shade the other way. So that is that. Hope that helped you, and have a good evening.